MPanel-FEA already has a satisfactory method of coping with Encastre poles, that is poles set in concrete in the ground, by taking the polyline which goes around the top of the poles and marking that as Encastre pole tops. Then when the model is built, the pole tops are given an extra spring, in effect, pulling them back towards their normal place, and the spring rate simulates the effect of the pole stiffness. And in addition, to allow for the fact that the poles during the installation will have been bent over some and will have generated a back force, the back force is correctly calculated and applied to the top of the pole as a point force. Because of this, when we solve for load case 0, we have a very quick solution because nothing really has to move. And if we plot out the display shape, you'll see that the display shape, essentially everything stays in the same place, which is what we would expect in load case 0. And although this produces the correct forces on the pole top, the correct tensions in the corner guides, the corner links, the correct stresses in the fabric, it does not show us the amount of movement and the direction of movement of the pole tops during installation. And for this reason, we've introduced an alternative method of making an FEA analysis on tensile structures with Encastre poles, and that is to mark the pole tops as being Encastre poles with adjustable links. And what that does is it allows the links which connect the sail to the corner, these links here, to change their length whilst keeping the same tension during load case 0. So they can be thought of as similar to turnbuckles that you are tightening up, changing their length without any significant change in their tension. And so if we go ahead now and build a model with the new style of Encastre simulation, we'll see that on the materials page that some of the links have been marked as adjustable. Some are marked as compressible, those of course are the poles, but the adjustable links will maintain their pre-stress value, which will be set in this table here, during the load case 0 relaxation, whilst being able to change their length at will. In addition, there has been no provision of back force, so we have not applied any back force during the to the initial conditions, and this means that the adjustable links will pull the poles in to an amount which will exactly equalize the structure in its force equilibrium which it would achieve during installation. So we can go ahead and run the solve for, and during the solution, instead of the instantaneous or very fast solution that we got before, where no movement was occurring, we now have a graph which shows that we have some movement occurring and then the solution occurs. And if we go ahead now and plot the displaced shape, you can see that the pole tops have moved in, and this link joining the pole tops to the sail has shortened to achieve essentially the same conditions that we had on the previous model, but we have a visual indication and a measurement that we can make of the pole top movement. And of course that pole top movement will have to be accommodated by whatever kind of adjustable link we have in the edges there. So this provides an alternative method of working with Encastre structures. And just to make it clear, the adjustable link is only adjustable if it can only change its length without altering its tension during load case 0. During higher load cases, load case 1, load case 2, when an external load is applied, then the link will behave as a normal fixed link, starting out at whatever length has been found for it during the load case 0.